Okay, please, my name is Richard Frempong, and then I'm in data science and analytics diploma, and then I'm in group 4. I'm presenting on cache mapping. So first of all, we're going to talk about the definition of cache mapping. So what is cache mapping? Cache mapping is a technique used to determine where a main memory block should be placed in the cache. It helps manage memory efficiently by deciding which cache line corresponds to a specific main memory content. Then we move on to how the cache mapping works and everything. This is the main memory processor, the secondary storage, the pages, and then the cache mapping itself. Then we move on to key terms related to cache mapping. So some of the key terms related to cache mapping are as follows. The first one is memory block. The main memory is divided into equal size partitions called main memory block. So when we say main memory block, these blocks contain the actual data or instructions stored in the memory. Then the cache line. The cache line is divided into equal partitions called cache lines. Each cache line corresponds to a specific portion of the memory. Then the block size. The number of bytes or words in one block is called a block size. It determines how much data can fit into each cache line. Then the tag bytes. These are identification bytes used to identify which main memory block is present in a cache line. They help determine cache hits and misses. Then the last one is number of cache lines, determined by the ratio of cache size to the block size. Then need for cache mapping. The need for cache mapping. 1. Cache mapping helps identify where data is present in the cache memory. Then the second one, it provides the cache line number for cache hits and guides where to fetch content from main memory in case of cache misses. Then we move on to primary aspect of cache mapping. So 1, we are going to talk about the main memory blocks and cache lines. The main memory is divided into equal size partitions called main memory blocks. The cache is divided into equal partitions called cache lines. The block size specifies the number of bytes or words in one block. Tag bytes are used to identify which main memory block is present in a cache line. The number of cache lines is determined by the ratio of cache size to block size. The number of cache sets depends on the ratio of the total number of cache lines to the associativity of the cache. Then we move on to the second aspect of it. That is the second one is cache mapping technique, and there are 3 common cache mapping techniques. The first one is direct mapping. So each main memory block maps to exactly one cache line. The cache line number is determined by the cache line number is determined by the lower byte of the main memory address. And the second one is fully associative mapping. Any main memory block can be placed in any cache line. It uses tag bytes for identification. Then the third one, that's the last one, is set associative mapping. The cache is divided into sets, and each set contains multiple cache lines. A main memory block maps to a specific set, and then the cache line within that set is determined using tag bytes. Thank you very much. My name is Richard Frempong. I'm in data science and analytics diploma, group 4. Thank you very much.